Alright, today we're going to talk about Pythagorean Theorem, section 5.7. Now, hopefully Pythagorean Theorem is one of those things that you recall. When you hear Pythagorean Theorem, a lot of times what do you think of?
A squared plus b squared equals c squared.
A squared plus b squared equals c squared. Nice job. And a lot of times we think of right triangles, because that is the relationship that is used for a right triangle. So today we're going to talk about Pythagorean Theorem. If you had to take probably just one concept and say which geometry concept is probably used the most in real life, it's probably going to be this one right here. Okay, Pythagorean Theorem is used probably more often than anything else. It's one of the most common things. Great. Okay, first off, vocabulary here. First thing you identify is a Pythagorean triple or Pythagorean triplet. A Pythagorean triple is a set of three non-zero whole numbers a, b, and c such that a squared plus b squared equals c squared. Essentially what it means is that when you use Pythagorean Theorem, you plug in whole numbers, you're going to get a whole number out. For example, 3, 4, 5. That would be like saying 3 squared plus 4 squared equals 5 squared, which is true. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. 3, 4, 5 is Pythagorean triple. 5, 12, 13, 8, 15, 17. These are some of the most common Pythagorean triples. Now, why do we talk about these? Well, these are the ones that you'd expect to see come up more often than any other. Okay, when you're taking a test, on an assignment, ACT, these are the ones that you're going to see more often than not. So if you can identify that it's a Pythagorean triple right away, it saves you a lot of work on the process. Okay, and again, we have a right triangle here, A, B, and C. Remember, C is always opposite the right angle. If I were to look at this, using the inequalities we talked about last week, which is my biggest side, A, B, or C? C, because it's opposite the biggest angle. Still the same properties we talked about last week. Now here's what we're talking about today. We're going to use Pythagorean Theorem to help us solve some triangles. So if I have a problem like this, where it gives me the hypotenuse, does everybody see how it gives me the hypotenuse? Now I need to solve for either A or B. It does not matter A or B. They put X as A. That's fine. You solve it. And then I get a radical. I'm going to leave my answer as a radical. Where's my Algebra 2 students at? Hey, how do I break down a radical? So for example, here I have the square root of 45. Okay, how does the square root of 45 break down? Well, it breaks down as the square root of 9 and the square root of 5. And what's the square root of 9, Claire? 3, so my answer is 3 squared of 5. That's how I break it down. One of your factors has to be a perfect square. Okay, Simeon's nodding her head because she's like, yes, we do this a lot. For example, let's say Simeon, put you on the spot. What happens if I have the square root of 50? How does the square root of 50 break down? So I have the square root of 25 and the square root of 2. What's square root of 25? So I get 5 square root of 2. Okay, that's how we break down these radicals into simplified radical form, which we're going to do a lot more of here in future. And then we get some tougher problems like this one over here to the right. Okay, now pay attention to this one because you will have a couple of these. I have x4 and x plus 2. Well, I plug it in, so I get x squared plus 4 squared equals x plus 2 squared. Now when I have x plus 2 squared, I have to think about what's it mean to be an exponent squared? Taking it what? Times itself. So that means I need to take x plus 2 and I take it times x plus 2. Well, and then I need to FOIL. This means I need to FOIL first, outer, inner, last. And when I FOIL, that's when I get x squared plus 4x plus 4. Now you're looking at that like that's a tough problem. But look at this. I have x squareds on both sides. Well, they just cancel. I'm left with 16 equals 4x plus 4. Subtract 4, 4x equals 12, x equals 3. So really I had a 3, 4, 5 triangle, my Pythagorean triple. Okay? Yes, that is a little bit tougher. That's a little more algebra to that problem, but we can do that. So let's talk through a couple problems here. Number 1. It says find the value of x. Give your answer in simplest radical form. Okay? Do I have the hypotenuse in this problem? Yes. So I'm going to say x squared plus 16 squared equals 20 squared. Well, what's 16 squared going to give me? 16 squared, 16 times 16 is 256. So I have 256 equals, what's 20 squared?
400.
400. Now I need to solve for x, so I'm going to subtract 256. X squared equals 144. And last step is do the square root. What's square root of 144?
12.
I get x equals 12. Great. Number 2. Blake, step number 2. How do I solve this one?
2 squared plus 5 squared equals x squared.
Yep, 2 squared plus 5 squared equals x squared. What's 2 squared, Blake?
4.
5 squared? What's 4 plus 25? And what's my last step going to be? Take the, what's square root of 29? It can't break down. So if it can't break down, I'm just going to leave it as the square root of 29. Leave your answers, stay as radicals. Don't put them as decimals. Don't type them in your calculator. Just leave them as radicals. If you can simplify them, do. If not, like a problem like this, it can't simplify. Just leave it as square root of 29. 3. How do I set up number 3? Chris, what do you got?
X squared plus 5 squared equals 8 squared.
Very good. X squared plus 5 squared equals 8 squared. What's 5 squared, Chris?
25.
So x squared plus 25 equals what's 8 squared?
64.
Subtract 25 to both sides. I get x squared equals what, Chris?
40. No. 30.
39?
Yeah. And then square root. And then. I don't think there's square root.
X equals square root of 39. Square root of 39 does not break down. What'd you say, Anderson? Okay. Now 4 is the tough one. Okay. 4 is the tough one. That's the one we talked about on the slide before. I'm going to erase some work here, so I have some work to solve here. Okay. Which one's my hypotenuse here, Caden? Which one's the hypotenuse?
X plus 1.
Okay, because it's opposite the right angle, right?
Yeah.
So I'm going to say x squared, so that's my leg, plus 9 squared, that's my other leg, equals x plus 1 squared. Is everybody good with what I did? Basically, just took what I did, A, B, and C, and plugged it in for Pythagorean Theorem there. Okay. Now I'm going to work it out. X squared is still x squared. What's 9 squared going to give me? 81.
Yeah.
Equals. Now, what's x plus 1 squared? Now, what's it mean to be squared again? Take it times its. So that means I need to do x plus 1 times x plus 1. I need to FOIL it. So first, x times x is x squared. Outside, x times 1 is x. Inside, 1 times x is x. And then 1 times 1 is 1. And then I combine the middle terms. What's x plus x? So I get x squared
Plus 2x plus 1.
plus 2x plus 1. Now I just need to solve. Does everybody see how I have x squared on both sides?
Yeah.
Well, I'm going to subtract x squared. And what happens there? They
Cancel out.
cancel out.
81.
So I have 81 equals 2x plus 1.
80 equals 2x.
I'm going to subtract the 1 on both sides.
X equals 40.
80 equals 2x. Divide both sides by 2.
X equals 40.
And I get x equals 40. So if I were to plug that one in here, I would have 40,
41.
9, and 41. And if you were to check that out, that is correct. 9 squared plus 40 squared does come out to get me 41 squared. Okay, so 4 is kind of the tougher part of this. There's a little more algebra and worth along with that. Take a couple seconds to try these two on your own. Okay, they give you both the legs. I want you to find the hypotenuse. So try these two on your own here. Number 5. How'd you set it up, Reed?
Number 5, I did 9 squared plus 12 squared equals x squared.
And when we do that, you get what for an answer?
Wait, you want the final answer?
Yep.
X equals 15.
C or x equals 15. Nice job. 6. How would I do number 6? Trent, how'd you set it up?
I did 6.
Yep.
7 squared plus 24 squared equals
Awesome. And when you do that, you get what for the answer?
I didn't do this.
25. Good work. Recognize those are all Pythagorean triplets right there. Take a couple seconds. Try number 7 and 8 on your own now. Jake O'Connor, number 7. What'd you do here? So you did a squared plus 9 squared equals 15 squared. Nice, because recognize it gave us the hypotenuse. When you do that, what do you get for an answer then, Jake? Yep. A equals 12. Nice job, because you have to subtract, right, to the other side and solve. 8. What'd you do from 8, Brock?
7 squared plus x squared equals 25 squared, and then plus 49 plus x squared equals 625.
So B equals what?
X equals 24. Or B.
B equals 24, or A equals 24, or X equals 24. Either way, all the same thing. Yep. Nice job. That is a correct answer there. Again, you have to recognize when you're given the hypotenuse, you have to make sure you subtract to solve. When you're trying to find the hypotenuse, you add to solve. Last thing we're going to talk about today is not only can this help us with right triangles, it can actually help us with acute and obtuse triangles as well. So for instance here, we already talked about Pythagorean triples. Okay, Pythagorean triples, 3, 4, 5, 5, 12, 13. Those two are probably the two most common ones out there. We'll talk about some more here in a bit. But I can use the Pythagorean inequalities theorem to help me as well. So a lot of times we recognize, a squared plus b squared equals c squared. Well, if a squared plus b squared is less than c squared, that actually gets me what is an obtuse triangle. And then if I have a squared plus b squared is greater than c squared, well, then I have an acute triangle. So they give me an example down here of the sides 2, 5, and 6. Well, the hypotenuse is always the longest side, right? So the hypotenuse would be the 6. So I'm going to say 2 squared plus 5 squared is what compared to 6 squared? 2 squared is 4, 5 squared is 25. So I get 29 is less than c squared, or 29 is less than 36. So that means this is going to be an obtuse triangle, because a plus b was less than c there. So that gives me an obtuse triangle. So it's the same thing as Pythagorean theorem. I'm just going to use the inequality to determine whether it's an acute or obtuse triangle. Okay? These are the common Pythagorean triplets. So when you recognize these should be kind of come to you right away. Now somebody asks the question, they go, well, why are these in red? Well, think about it here. If I were to take 3, 4, 5 and I take that times 2, what do I get? If I take all those sides times 2, what do I get?
6, 8.
Hey, look. I get 6, 8, 10. If I take it times 3, what do I get?
9, 12, 13.
Hey, look.
Yeah, times 4.
If I take it times 4, what do I get? Does that work anytime?
Yeah.
Yeah. Let's say I take it times 10. What's another Pythagorean triplet? 30, 40, 50. Okay? All Pythagorean triplets can be based off of this kind of root of 3, 4, 5. Same thing here, 5, 12, 13. If I take it times 2, what do I get?
10, 24, 20.
Hey, there's another Pythagorean triplet. So a lot of times you'll get like some high numbers. Well, you can make an easier problem by just reducing it. Okay, and if it's a reducible Pythagorean triplet, it's the same thing. All right. So let's classify these triangles. Tell whether the measures can be the side lengths of a triangle. If so, classify the triangle as acute, obtuse, or right. So remember, a squared plus b squared is less than c squared is obtuse. And a squared plus b squared is greater than c squared is acute. And what happens if I get a squared plus b squared equals c squared? What's that going to be? It's a right triangle. So I'm going to say 4 squared plus 7 squared, and I'm checking compared to 9 squared. 4 squared is 16. 7 squared is 49. Now I'm comparing that to 81. What's 16 plus 49?
60.
65. 65 is less than 81. So that's going to be an obtuse triangle.
So what if how do you get if it's right?
How do you get right?
If they're equal.
If they're equal. So let's check 10. 10, 13, 16. So I square them. 10 squared is 100. Plus 13 squared is 169. And I'm checking that in relationship to 16 squared, which is 256. 100 plus 169 is
269.
269 is greater than 256. Therefore, it is acute. Nice job. And last one, 11. 8, 8, and 11. So I have 64 plus 64, and I'm checking that compared to 121. 64 plus 64 is 128. 128 is greater than 121, so that is acute. Okay, so using that same idea there. Take a couple seconds, try these three on your own. I'll let you know right now. 13 is a trick question. Let's walk through number 12 here. When I work it out, I get 9 squared, 12 squared, 15 squared. 9 squared is 81. 12 squared is 144. 15 squared is 225. When I do that, do they come out to be what? Equal. If they're equal, that means that it is a right triangle, because that's basically what Pythagorean Theorem states. Now 13, Mr. Hutton, walk us through this one. What happened on number 13?
Those lengths don't make a triangle.
It's not a triangle. How do you know that, Blake?
Because 14 plus 5 is 9.
Yeah. A lot of you wanted to work it out and be like, it's an obtuse triangle. But if you look at it, 5 plus 14 is not greater than 20. Therefore, it's not even a triangle. If, let's say I change 20 to 18, now is that a triangle? Yeah, now it's a triangle, and now I can compare it. But because the two sides are not greater than the third side, it's not even a triangle. Can't even compare it. And last one, 14. Becca, what do you get? Yeah, it's an obtuse triangle. When you work it out, you get, let's see, what was it? 16 plus 36, and that was less than 81, right? Nice job. Here's your assignment.